Here we go. We have two cranes. They're working together to lift an object, theoretically because maybe they can't do it on their own. Okay? So they're working together to lift an object, a really heavy object, by the way. We're trying to figure out the tension in each of the cables of the crane. As you can tell, I kind of set up a vector diagram. This is what I was doing at the end of yesterday, where you can see crane, the blue one. Oh, did I switch the colors? That's annoying. Whatever. We have the green vector on the left for the blue crane over here. We have the blue vector on the, I said it backwards. Anyway, this guy for that crane, this guy for that crane. So we have U and V working together to lift G. Now hold on. If the box is being lifted, even though gravity is pulling down, we actually need to change this just a little bit. Because even though gravity is pulling down, the cranes are working together in order to pull this up, right? So what the cranes are doing are lifting it up and canceling out the gravity that's pulling down. Long story short, what force do you have to exert on an object to be able to lift it? The equal force of what gravity and weight are pulling it down with. You don't have to exert more force, you just have to exert equal force. If you are able to counterbalance or counteract the force that's trying to hold it on the ground, then you will be able to lift it because you'll negate the you'll negate what's trying to keep it on the ground. So long story short, U plus V has to equal G. U plus V has to equal the weight, basically, in this case, because weight is combined with gravity. You guys know, or at least you've heard about, like on the moon, you weigh differently because gravity is different, etc., right? Same kind of thing going on here. So what we need to do is add U plus V. Do you guys want to start translating stuff and using geometric triangles and parallel lines and transversals and law of sines, law of cosines to solve? Or do you want to go into components and add down?
Easy.
Yes, let's do components and add down. Austin, sound good? So, if we want to do components and add down, we have to actually make components. Hopefully if you were working on homework last night, you already have had some practice on making a vector, expressing a vector with its components. To be simple, can we go ahead and just do the side carets? We could do the i's and j's, but who wants to do that? Now, before we can make components, we need the angles to be behaving in the same way? Not necessarily. Not necessarily. We could go ahead and say this one's 44.5 and this one is 180 minus that guy. That starts to get a little bit complicated. What we can do is use the formulas that we saw yesterday, where A is equal to magnitude of the vector, cosine of theta. Remember these formulas? B is equal to magnitude, sine of the theta. Those are in your notes for how to convert back and forth. We're going to use those to get the components. And let's start with vector U. Do we know U's magnitude? No. Oh, well, this is going to get really messy really fast unless we say, all right, fine. Let's make U's magnitude. Let's make him X. Sound good? And let's make V's magnitude Y. Just so we don't have to keep on writing like the yucky magnitudes. So then for U's magnitude, we'll call him X, and we'll say X cosine of 24.3. Hopefully your calculators are in degree mode. The other component will be X sine of 24.3. Plugging into these, once again, formulas from before. Now, for V, we're going to go ahead and say, all right, so we have Y sine of 44.5. And Y, oops, not sine. Who's supposed to be in the horizontal component? Cosine, good. And then Y sine of 44.5. And we're almost good, except we're allowed to use these angles as they are written as long as we determine the signs. We have to determine the signs ourselves because cosine and sine of those little acute angles will always be positive because those little angles are supposed to be in the first quadrant. Now, is vector V going positively to the right and positively up?
Yes. Wait, V.
Yeah, V is. So V, we're going to keep a positive. We're going to say, you know what? Positive is great. We like the positive. V, we like the positive. Now, U. Is he headed the same way as V? No. What's different with U? Which component do I need to make negative?
The X.
Yeah, I need to make the X component negative. So I can keep these little angles and make it easier to plug in, not have to worry about like 180 minus, but I do need to make the signs what I need them to be to reflect which direction the vector is going. Now, once I have that all set up, I can say, sweet, what is supposed to be the combined effect of these two vectors? It's supposed to be G. Now, look at G's movement real quick. Now, I know that he's kind of weird and he's kind of down below, so let's just check this out, okay? Question. What is the box's angle? 90 degrees, right? Because he's just going straight up. He's not going to the right. He's not going to the left. He's not going at an angle. Well, he is going at an angle, but he's going at a 90-degree angle if you were to think about it that way, right? So if he's going at a 90-degree angle, I can say, all right, fine. Let's go ahead and do his magnitude, cosine of his angle, his magnitude, his sine of his, wait, what is his magnitude? Do we know the force? Or the weight that he is pulling at? Huh? Zero. It's zero once we cancel everything out, but we need that these two cranes to equal what total magnitude? Yeah, 20,240. We need them to cancel that out. So we're going to go ahead and use the 20,240 and say, okay. So we have 20,240 cosine of 90. 20,240 sine of 90. Wait, what is cosine of 90? And what's sine of 90? Oh. So ultimately what we need to set this whole thing equal to is, once we simplify, 0 horizontally and 20,240 vertically, which kind of makes sense because this box hopefully isn't swinging back and forth. The box is going straight up. So the horizontal is 0. The vertical is 20,240. Now, this might look a little bit messy to you. Unless you realize, doesn't horizontal plus horizontal equal horizontal? And doesn't vertical plus vertical equal vertical?
Yes.
So if we're trying to put this all together, we can make a system of equations. And the system of equations says, hey, I have two pieces of information, both with x's and y's. That I can set equal to set equal to an answer. System of equations I can set equal to an answer. And kiddos, before I even write the second system of equations, I don't think elimination is a good idea. Because these numbers are disgusting. But what could we use? Substitution sounds great. And maybe even substitution solving for y, because the x is negative. So we could solve for y from this equation. We could get, all right, cool, y is equal to x cosine of 24.3 divided by cosine of 44.5. Some of you might want to start going to your calculators right now, but you're going to round and you're going to introduce error, so don't do that. Now we have an expression for y that we can use in the second system of equations, which would be the other side of the equation, which are the vertical components, x sine of 24.3. There's a lot of points going on there. Plus y sine of 44.5 equals 20,240. We have a y that we can plug it in. It's not pretty. But let's go ahead. I'm going to actually insert a new page real fast because I'm running out of room. Actually, I can plug below. No, probably not. That sounds bad. Let's do this instead. So when you go to plug in the y you're going to have, it's not pretty, it's not gorgeous, but we got this. Sine of 24.3 plus we have x, and I'm going to rewrite this just a little bit. Let's see if it makes sense to you. I know you can't see it quite yet. Hold on, I have to write it in a different page. Cosine? 24.3. It'll be up in a second. Sine of 44.5 all over cosine of 44.5 times x equals 20,240. So I plugged in y to x and I got the following. Let me zoom in a little bit. Now what did you guys see I did with all the stuff that was being multiplied and plugged into the second term? Why did I put the x out here in the front?
Because we can divide by all that mess.
Yeah. I don't actually still have to plug anything into my calculator because I can say, hey, don't both terms have a common x I can pull out? Then I'm going to have sine of 24.3. Thank goodness for calculators that can do all this for us. We could be really sneaky and do cosine of 24.3 and say, hey, who's sine over cosine? Isn't that tangent? Just make it easier. Slide rule. This would be a really messy problem. Then x would equal, I would use your big ol' alpha y equals button on this puppy, right? You can do your 20,240 in the top. You can do your sine of 24.3 plus cosine of 24.3 times tangent of 44.5. Not gorgeous, but that's something I can plug in all at once without introducing any error in order to be able to solve. So alpha y equals, I'm using a big old fraction thing to make life easier, 20,240 over sine of 24.3 plus cosine of 24.3 times sine of 44.5, no, tangent, 44.5. And fairly quickly I can figure out x, which is the magnitude or the tension of U, is equal to 47,544.066, technically pounds. We'll say pounds of force for right now, just for our simplistic way of dealing with it. Can anybody back up that number for me real quick? As we all know. Sounds right. Did you not
Seems
double
like
check?
it makes sense.
Oh, wait, I didn't do a parenthesis.
Yeah,
Struggle. I didn't end sine of 24.3. We should always double check. So
minus 10.
how about 15,484? Is that better?
Big difference.
484? Is that better? Uh-oh. Sine of 24.3. Cosine of 24.3. Tangent of 24.5. I think I have it. 484.094. Okay. We're double checking. Don't worry, I typed it in wrong too the first time. As they're double checking, considering, yeah, Nathan? Cool. Assuming that's right. Oh no, I still need who? The other dude. But wait. Guys, whenever we do substitution, isn't there like an equation just waiting to be plugged in as long as you can solve for one? All we gotta do is plug it in. Cosine 24.3 over cosine of 44.5. So we're just gonna go ahead. Cosine over cosine. And say he is gonna equal x times cosine of 24.3 all over cosine of 44.5. I'm just going to steal this number, right? And plug him in with my calculator, my calculatrice, my calculadora. So let's go steal him. No rounding, hopefully, times cosine of 24.3 divided by cosine of 44.5. And we get 19,785.83. Okay. Whew, those calculations took a little bit longer, plus I made a mistake along the way. Lame sauce. However, He's not impossible, he's just a bit messy. Long story short though, can you imagine the geometry that would have taken if we hadn't done components? The components were hard enough. So we separated each vector into its components and then we added them together. Now, the math was messy, but maybe the process, or at least the startup, made sense. Two cranes working together to do a single load of the box going up. So take vector u plus vector v, set it equal to the other one, and then do all kinds of math, yucky math, but math to solve. The next example, the math is easy, the setup is hard. The next example, the math is easy, the setup is hard. I want you guys to go ahead and draw this picture and highlight it. And as you draw this picture and highlight it, I'm going to tell you a few things as to what the pieces of the picture are. This is an inclined plane problem. The last one was two things working together on one single object. This one is some sort of object like a car, a truck, a something trying to counteract somebody on an inclined plane that's trying to roll down it.
Got a question.
Go ahead, but you better be writing the diagram.
For the last problem,
Yeah.
how did you get the 90 degrees?
Oh, because I looked at the picture, and the picture where the box was, right here, his vector is at 90 degrees. Does that make sense? This guy was tilted, this guy was tilted, this guy is perfectly 90 since he's going straight up.
Okay.
Okay, inclined plane. Let's talk about some vectors. First of all, on this example, there are a few different points. Let me make sure you can see where the points are. Here is point E, here is point D, here is point B, here is point A, here is point C. I'm going to actually go ahead and zoom in on this guy. For somebody or something on an inclined plane, long story short, we have a vector going down, a vector going up, a vector going down, and right here is a right angle. Right there is a right angle. Okay? Couple things to label. This guy right here we'll say is theta, and theta is the inclination, aka the angle of inclination, aka in this example our theta would be 15 degrees. Then we have a few other vectors.
Wait, how did they get the triangle points?
Well, there's the incline way over here, and basically with some quick geometry, if I had time, I'd be able to show you how this angle ends up being congruent to that angle. It has to do with parallel lines, because this one is parallel to that one. There's a transversal. It just kind of goes together. Okay. But, long story short, we have a force vector down below, and this is the force to pull the trailer up the ramp. That's the force to pull. We have the weight of the trailer. I can do him as W, I guess. We have the weight of the trailer. I think weight has to do with gravity, and gravity goes straight down. And then we have this perpendicular force is the other side of the triangle, but he usually isn't solved for, okay? If we take all of the pieces of the puzzle, I told you the math is easy, the setup is hard. This triangle is something that you would want to study for this word problem, if this word problem was on your test, out of the three. This triangle makes it easy because, what do we know? From the problem, we know a force of 600 pounds, so who is that? So we can say that F is equal to 600 pounds, and more specifically, the magnitude of F is equal to 600 pounds. What are we trying to find? We're trying to find the combined weight of the boat and trailer, which is that one right there, due to gravity. And then what else are we given? Theta is equal to 15 degrees. Kiddos, if this is a right triangle, how do you solve, exactly, how do you solve for the unknown piece if you have the opposite and you have the angle and you're trying to find the hypotenuse? Opposite and hypotenuse, what trig is that? Sine of 15 degrees is equal to 600 over the magnitude of W, which is who I'm trying to solve, or you can just call him X. So therefore, to find W, all we have to do is solve. I know it's a little tricky. Here's your right angle. So I have my opposite, that's this guy. We have my hypotenuse, that's that guy. The adjacent, we don't really care about. All we gotta do is plug it in, and we got him. And it's gonna be in pounds again. Plug him in, we got him. The setup was hard. The math was easy. This one, the setup is hard, the math is easy. First one, setup was easier, math was hard. Second one, setup is hard, you need to know that triangle, math is easy. It'll be on there, it'll be on the video as well. We're not going to be able to finish this whole one. But first of all, I want you guys to see something in this problem. You see bearing? Okay, if you have a bearing one in your homework, maybe look at it and put it in parentheses in your mind because bearing will not be on the test. You're going to have nicer angles on the test. So I'm going to actually change this guy just a little bit. I'm going to change this guy just a little bit just for sake of simplicity. Since you're not going to have bearing on the test, I'm going to say instead its angle is, we have a whole other 60 seconds, so I'm going to keep you an extra 30 on purpose just because you guys are packing up. That's unacceptable, just to waste time. Its angle is equal to 330 degrees, bearing 32, that's going to end up being 28 plus 90. That's going to be 118 degrees in standard position. Long story short, we have a plane that is headed this way, 118 degrees. We can go ahead and call this guy P. We could find this guy in components because we have not only that part, but also this part, magnitude and direction. Who else do we have in the word problem? We have this guy called wind, working against the plane. From the southwest, this is kind of tricky, the southwest, if they don't tell you, we must assume it's this guy. Perfectly in between, which would be a 45 degree, which we could go ahead and call him 45 degrees in the third quadrant. Okay, let's wait 30 more seconds just because. Yeah, 215, right? So we have this guy's theta of the wind is equal to 215. I have magnitude and I have direction. Kiddos, if I want to figure out what's going on with the plane plus the wind, 10 more seconds, the plane plus the wind, what makes this math easier? Put into components or combination form. All right, kids, get out of your homework is due on Monday. I might try to copy this answer into the notes so you guys can use it. Bye, guys.
How many sections are left? What is the time?
This is 6-3, 6-4, 6-5, 1 day, on 6-4, 2 days on 6-5, test. So Monday, Tuesday, Wednesday, test on Friday, Friday.
Oh dear. Alright, well.
Bye, everybody.
Bye, have a good weekend.
Okay, you guys too.